This is part 2 of 7, diving into having a 4K display on a phone. If you'd like to see the full episode in context, it's available already right here. Otherwise, let's jump into it. We can't continue this conversation without talking about display density. There are various units of measurement, but by far the most common one is pixels per inch, so that's what I'm going to be using here. Effectively, a high pixel density is when you have the pixels very tightly packed together, versus a low pixel density where they're very loosely packed together. If you make the display size smaller, you're effectively making their density higher because the pixels are closer together. Conversely, if you make the display larger while keeping the same resolution, then you're effectively making the density lower because the pixels are more spread out. The relevance of this is that the myth really started to gain traction when a 5.5-inch display on a phone was quite large, and now it's quite small. So the display sizes have been getting larger, meanwhile the resolutions have been getting lower, which means that two different factors are reducing the display density. So to put some numbers on how much it's going down, this phone here has a 4K display on it, and it has a PPI of 807. This phone has a 1440p display, and it has a PPI of 568. So compare that to the more recent Sony Xperia 1 Mark IV, that has a pixel density of approximately 643 ppi, so it is much closer to the 440p display of several years ago. It seemed like time for a proof of concept, so I wrote a quick Android application which just had a few little test patterns. The reason I did this rather than using photos was because I didn't want there to be any possibility that compression or any other assumptions could be getting in the way and influencing the result. It also meant that I could animate the pattern in a predictable way. So I built the app, stuck it onto my phone, and I couldn't see it. I could see it moving, but I couldn't see which direction it was facing. Am I wrong about this? Well, if we have a look at how much video is remaining, that's a bit of a clue. So, let's dive into it. The first thing I wanted to understand was, what was the display actually displaying? So I pulled out one of my old cameras from 2006. It's a 6 megapixel job. It was always very low end, but its macro was pretty good, so it was really good for this task. It does have one limitation, which we will discuss later on in the video. My initial setup had the camera on a tripod and the phone on a little mini tripod, and I would then put the two things together and I'll take the photos like that. This had so many factors for inconsistencies and errors that it just wasn't worth continuing. So what I ended up doing was putting the phone flat on the table and then facing the camera directly down on top of it, and then I had much finer grain control. I could control the phone remotely, so then I could iterate the pattern, and I could control the camera via timer, so I was able to be completely hands-off from the whole setup. I was able to remove all the bumps and wobbles and all the inconsistencies. I used the focus of the camera to determine how far the camera was away, so therefore all of the patterns between all of the different test shots and all the different phones, I've got them pretty close to consistent, so we can compare them side by side quite nicely. So, it was time to look at the results. Okay, so at this point we need to discuss pentile displays. If we have a look at what we think of as a traditional RGB display, you have the red, green and blue, and they're all very close related to each other. You have one complete set per pixel. So if you have a pixel over there, it's got a red, a green and a blue. And you have a look at a pixel over here, and it's got a red, green and blue. And that's all fine. Pentile displays share some of those elements. And that comes with a whole heap of advantages and disadvantages. So we probably need to dive into that a little bit now. The first thing that surprised me about pentile displays is that I thought they were a fairly niche thing. I thought it was just a few Samsung devices and that was about it. In my testing, of all the phones I tested, there was exactly one device that was not a pentile display. And I ended up going and doing a bit more reading on Wikipedia, and it said, as of 2021, almost all OLED screens and portable consumer devices use some form of pentile subpixel layout. So yeah, that very much mirrors my results. So that's quite interesting. LCDs don't have to have a rectangular layout like this one does. They can come in all sorts of different forms. This 4K Sony is an excellent example of that, where it's using a sort of hybrid between the two, and we'll look at that a bit more closely in a moment. So most displays that you're going to be looking at 1080p or above are going to be pentile, and that makes this next section very interesting. So pentile displays have a number of pros and cons. One of the big ones is that because the elements are being shared between multiple pixels, the subpixels are not necessarily in a straight line. This can actually help reduce the screen door effect. They can be cheaper to manufacture because there's less complexity for a given resolution. If they're designed for it, they can be amazing at doing different resolutions that aren't necessarily multiples of each other on the same panel. Pentile displays can have better luminosity, and that's a bit more of an involved conversation, so we'll just leave it alone for now. They tend to do better at having less colour bleed than what we think of as traditional displays. For example, here you can see there is some red and some blue on both trailing sides. Whereas if you have a look at this Pentile display, you can see that the shape is pretty smooth, but also the colours are well balanced. But that's not some universal truth. Have a look at this one here. They could have balanced the colours, but they didn't, and I don't understand why. They probably had their priorities elsewhere, I guess. Pentile displays tend to have fuzzier edges than non-pentile displays. This is because subpixel elements are shared between pixels, which means that the boundaries between one pixel and another are less clear, and they're also less consistent. So pentile displays rarely benefit from a higher resolution, so that these defects become less visible. So while edges may not be as defined as non-pentile displays, they do handle shapes really, really well. That's because they really thrive when there's lots of neighbouring pixels right beside each other, because then they can really optimize for that shape and keep it colour balanced and smooth. I spent weeks looking at close-up photos of phone displays. I could talk for hours about all the interesting tangents that went on exploring how these worked, but there's a few specific ones I want to call out. Have a look at the Samsung. You can see that vertically we've got one single pixel width. But then when we look horizontally, it's actually two. So these two lines here, those are supposed to be one. However, we want to draw somewhere in the middle. And we don't have any red pixels in between there. We have green ones, but we don't have any red ones. So we have to straddle it, go either side, and that's why we get two dim lines rather than one straight, clear red one. And that's a really good example. You can see that with red and with blue, we sometimes get that division like that. But with green, we don't.
Whoa, Future Kev here. It's a bit more complicated than that. It deserves a whole blog post by itself. But just to sort of highlight a little bit here is what we think of as a traditional RGB display. And you can see the red, green and blue, that's one-to-one mapped and everything's coming through cleanly. And then if we go and have a look at a pentile display here, at another pentile display here, and you can see these ones are behaving completely differently again. So just understand that this behaviour varies between different types of display. It affects red, green and blue, and it affects horizontal and vertical. Anyway, with that, let's get back to the video.
Now look at the Sony 4K display here and notice that the white dots are not going straight. I would have expected them to be all diagonal one way, and just continue for the whole display like that, but they actually alternate every few pixels. I don't know why they're doing that. My best guess is that they're trying to make sure that any distortions caused by the pentile layout is not uniform throughout the entire display, and so then that sort of diffuses and disguises the problem. I've got a few minutes with some family to photograph their phones, so then I'd have a more diverse library of phones that I've looked at. With other people's phones, I specifically haven't been changing things like the system font size or light mode versus dark mode, so these can't be directly compared to my other results, but we can still make some interesting observations from them. I was really happy to photograph an iPhone 12 Pro because those displays have been talked about for so long, and it was just really interesting to see what do they actually do. I was actually surprised. It was better than I was expecting it to be. One of the things that they've done really well is that the space in between the subpixels is very small. There's very little black there. This means that as hard as you look, you're going to really struggle to find any screen door effect on there. In fact, I'd go so far as to say you could probably lower the resolution of that quite a lot, and you would probably still not get any screen door effect on there. The other thing that I thought was really interesting with the iPhone 12 Pro is that I'm getting some alternating colours there. I originally thought this was a limitation with my camera, and we'll go into more detail about that in just a moment. But you can see on this photo, the whole area is really nicely covered. It's all showing, all the colours are showing correctly. So I think it was just simply an interaction with the refresh rate versus the shutter speed. I think that phone has a variable refresh rate, so it could well be some factor along with when one of us last touched the phone versus how long it took me to take the photo. The Samsung Z Flip 3, that was really interesting as well. It was my first time looking closely at a foldable, and they've definitely prioritised different things to the other phones that I've looked at. This one surprised me to the degree that I thought that they weren't actually using the sub-pixel resolution and they were just simply going, right, here's a block of 3, here's a block of 3, here's a block of 3, but that's not actually what they're doing. It was only after I'd spent a fair bit more time exploring the photos that I'd taken that I got the answer. Yeah, it is using the sub-pixel resolution, but it's not as obvious as it has been with almost every other phone I've taken. For pretty much all of the phones that I've looked at, this is true, but especially with these two phones, it would be really interesting to spend a lot more time diving in with more test patterns and sort of exploring what they do to really understand what they do. But what I got was really interesting to see, so it was definitely worthwhile. The last thing I wanted to comment on with this display is one of the complaints that people have had with some previous Samsung devices was that the colour saturation on the OLED displays was too strong. And that complaint is often said by cheap budget phones that have OLED displays as well. But you can see in these test patterns here that, sure, I'm displaying these pure colours, but we're also getting some neighbouring subpixels coming in there as well. Now, once again, this is something that I would explore more if I had more time with the phone, but I don't know whether it is Samsung going, hey, look, we can make the things a little bit less saturated if you want, or whether it is, hey, we need more brightness, let's put all the hands on deck and we're going to get as much light out as possible.
In part 2, we've discussed what is effectively being displayed. We've talked about display density and how it has lowered a lot in the time that the Smith has been floating around. We've talked about how Pentile and other displays work, and how that affects what we can and can't see, and what side effects those have. And we've looked at a couple of other interesting phones. If you'd like to see the full episode in its entirety, it's available right now there. And if you'd like to see a playlist of what's available so far, that's here, and like and subscribe.